Very good morning, my dear friends. Myself, Dr. M.H. Chennaya, and in today's video, we are going to study the development of the lateral surface of a cone of the given dimension, diameter of base 50 mm and height 80 mm, which is being cut by a section plane which is perpendicular to VP as given here, normal to VP, and parallel to one of the end generators. So when the section plane is perpendicular to VP, it is seen as a line in the front view. And friends, here let us first of all place the cone on HP, obtain its top view a circle and front view a cone, a triangle. So I am going to mark the XY line, and here I am going to mark the top view, that is a circle of diameter equal to 50 millimeter as specified in the question, and we'll divide this into 8 equal parts since it has no edges to draw the development. So we'll mark this as A, B, C, D, E, F, G and H. And friends, you will obtain O. This is O, the apex of the solid. We'll project lines from here, from all these corners, like A, E, etc. And on the XY, you will get A dash here. This is E dash. From the center, we will draw a vertical line to the given height of 80 millimeter. So I will just mark it somewhere here. This is O dash, and the height of this O dash, or the height of the pyramid, the cone is 80 mm. We will join this O dash to A dash, O dash to E dash, O dash to C dash G dash. This is C dash comma G dash, and the axis is perpendicular to the HP. This is O1 dash, and friends, here you will get two more lines, and on which OB and OH lie. So this is OB and this is OH. This is the base of the solid. Now this is how the solid looks in the front view, and this is the top view. This has got a diameter which we show as 550. 550 means the diameter of this circle is 50 millimeter. So, friends, after obtaining the projections of the cone, that is the top and front views, let us study about the section plane. It is cut by a section plane which is normal to VP and parallel to one of the end generators. What are these end generators? These are the end lines in the front view. That is O dash A dash and O dash E dash are called the end generators. That is end generators. So there will be two end generators, O dash A dash and O dash E dash. The section plane is to be parallel to that and at a distance of 10 millimeter from that generator. So friends, here I am going to mark a line representing the section plane at a distance of 10 millimeter from there. Say this is the section plane SS, which is cutting this solid, and this is being parallel to this, and this distance is given to be 10 mm. Remember friend, this is the distance between the parallel lines, generator and the section plane, and hence it should be a perpendicular distance like this, not at an angle. Now friends, you have been asked to draw the development of the larger part of the lateral surface. Larger part is what? When the section plane is cutting the solid, this is one part of that, and this is the second part which I am going to draw show it as a full line, and only this part is to be taken for drawing the development. This part below the section plane, this is removed. So friends, we have located this section plane at a distance of 10 millimeter from the end generator, and we have to draw the development for this. Now friends, to draw the development, we need to have first of all what is the sector angle or the influid angle. That is, theta is given by small r by capital R into 360 degrees. So small r is the radius. Diameter is given to be, as by here, r is equal to d by 2. Diameter is 50 by 2. This is 25 mm at the radius of the base. And this capital R is the length of the generator, true length. This last line O dash E dash, which is also equal to O dash A dash, which is measured using the scale after the construction of this front view. So you will get some length. So you can put the value and obtain theta. So I have not calculated the value, so you will get some angle which is measured using this formula. So once you have this angle calculated, let us commence the development. Now friends, let us draw a sector which has got the radius r. This is slant generator length, and here we know the angle. So we are going to draw an arc here. So this will indicate the sector angle, that is theta. Say we have calculated what are the value from that formula. And friends, here this is r, this is also equal to r. This r is equal to O dash E dash or O dash A dash. It is a true length because this end generator is parallel to VP, and this is a true length. R is equal to true length. Friends, the section plane is cutting the generator O dash E dash here, OB and OD and OF at this point. Here you are getting OC and OG, and 1, 2, 3. It is cutting 2 plus 2 plus 1, 5 generators. It is cutting, and it is also cutting the base A dash E dash. To know where exactly it is cutting, try a vertical line from there. It is cutting the periphery of that base here and this point. So we have got 2 points here, 2 here, 2 here, and 1 here. Let's see how to obtain these points in the development. And what are the angle you have got is this sector is to be divided into 8 number of equal parts, because the circle is divided into 8 parts. So 2 parts I have made, then again 2 more parts here. So this to be further divided into 8 total number of parts. So you can just count here. There are 1, 2, 3, 4, 5, 6, 7, 8. Now, after getting that theta and the development without section plane, let us see how to mark this. Friends, a portion of O dash E dash is removed. You can start the development from E in the base or A. It doesn't matter. So see, I am starting from E. After E, F, G, H comes. Then after H, again A, B, C, D, A, B, C, D, and this is point E. The last 2 lines generated should have the same marking. Friends, now let us see where all the section plane is cutting the solid. Friends, O dash A dash is cut here. This is the true length line. So take this measurement on OE, O dash A dash or OE. So say I am taking this point, 1 point here, and OE another point. Next friends, O dash D dash and F. This is D dash F. OD and OF are cut here. This is not a true length. Hence, I am going to shift that to the last line and take that measurement on OD and OF. OD and OF. This is OF and this is OD. This is over. We've taken this also. Next, come to this OC and OG. Generators OC and OG are cut here. O dash C dash and O dash G dash are not true length. Shift that point to this. Take this measurement on OC and OG. This is on OC and this is on OG. OC, OG we have got. Next friends, we got the points 1 plus 2 plus 2. 5 points you have got. Then let us move down to the point where it is cutting the base. Base is cut here. So it is between G and H. G and H, you have a point between G and H. Okay, point. And similarly on A and B, B and C, also to be marked. Probably it comes somewhere there, and here also it comes here. Okay, points. Friends, join all these points by a smooth continuous curve. So friends, I am going to join this like this, and again this. So these two curves will have the same curvature, and the portion above that is retained. So this I am going to show by dark line, this by dark line. And friends, what is not to be shown in thick line is this part of the generator. They are all removed here. From O, on OE this part is removed. Similarly, this is removed, this is removed. The portion here is retained. This is removed and this portion is retained. So A, B and A should be there. A, B and A should be. So this is to be darkened. Friends, this is the development of the lateral surface of the larger part of this cone, which is cut by the section plane, which is normal to VP and inclined to HP. In fact, they ask you to find out what angle the section plane is making with HP. You can simply measure this angle and keep the answer. This is the angle the section plane is making with the horizontal plane. Friends, I hope the presentation was interesting, and after going through this video completely, if you like the video, do give a liking to it and share the information with all your friends without fail. Have a wonderful day.